So welcome again. So we are going to solve question 3 from the assignment given. So expand in Fourier series the function f of x equals to x in the interval 0 to 2 pi, and hence use the series obtained and what was obtained in 2 to find the value of this other series here. So let's start by solving the series for this function. So remember, this is the series for question 2. So we'll require this one for us to evaluate the last part of that problem. So let's call this one star, solution in 2. So question 3. So remember that Fourier series is given by a0 over 2 plus summation n1 to infinity an cos nx plus bn sin nx. So this is by definition. So where a0 is 1 over pi according to the problem, and then the interval of integration is 0 to 2 pi, and then f of x dx, and then an is 1 over pi, integrate from 0 to 2 pi, f of x cosine of nx dx, and then bn is 1 over pi, integral 0 to 2 pi, f of x sine nx dx. So these are just the building blocks of the formula. So then, so a naught would be 1 over pi, integral 0 to 2 pi. The function is x, then dx. So this will give us 1 over pi, x squared over 2, 0 to 2 pi. So this will give us 2 pi. And then an will be 1 over pi, 0 to 2 pi, x cosine of nx dx. So use integration by parts relate u to be x, which means du will be dx. dv is cos nx dx, which means integrating this one, v gives you sine nx over n. So an will be 1 over pi. So uv is x sine nx over n, 0 to 2 pi, and then minus v du. So we have 1 over n, integral of sine nx dx. Now when you put 2 pi here, so sine of multiples of 2 pi is 0, and then you put lower limit 0. So therefore this part will just be 0. So an reduces to minus 1 over n pi, integral from 0 to 2 pi of sine nx dx. And then we carry out the integrations, have minus 1 over n pi. So integrating this one will be negative cosine nx over n, so 0 to 2 pi. So when you put in the upper limit, so this same thing can be written as an 1, so minus minus is positive, n squared pi, and then cos nx 0 to 2 pi. So when you put in the upper limit, we get cosine of multiples of 360, that is 1. So it's the same thing as saying 1 over n squared pi into 1 minus cosine of 0 is 1. So this will be 0. So therefore an will be 0. And bn will be 1 over pi integral 0 to 2 pi of f of x is x and then sine nx dx. Also, you use integration by parts so that you let it to be x, which means du is dx, and then dv is sine nx dx, which means v, integrating this one, is negative cos nx over n. So which tells you that bn will be 1 over pi. So uv will be minus x cos nx over n. So apply limit 0 to 2 pi minus v du. So plus 1 over n cosine nx dx, 0 to 2 pi. So this is what we have. Now this can be written as 1 over n pi, say minus, and then x cos nx 0 to 2 pi, and then plus, so integrating this one, we have 1 over n at times sine nx over n 0 to 2 pi. And then remember, sine of multiples of 360 degrees is 0, and sine of 0 is 0. So this is the same thing as 1 over n times 0, and all this goes to 0. So this is bn. So bn will be, so putting in upper limit, will have minus 1 over n pi into 2 pi cosine of n times 2 pi. So lower limit will be 0. And cosine of multiples of 360 degrees is always 1. So which tells us that this is the same as minus 1 over n pi times 2 pi. And then this one, n and n cancels, so we have minus 2 over n. So therefore, Pn equals to minus 2 over n. Now, using the values of a naught, b naught, bn, and an, the series becomes, and the Fourier series is, so our f of x is x given by a naught over 2. A naught was 2 pi, so 2 pi over 2 is pi, and then plus summation n from 1 to infinity. An was 0, so we don't have 0 times cos of nx is 0. So just bn, which is minus 2 over n sine nx, which can be written as x equals to pi minus 2 summation n1 to infinity of sine nx over n. So you can write it in expanded form as x equals to pi minus 2 into sine x, and then plus sine 2x over 2 plus sine 3x over 3 plus other terms. So this is the Fourier series of the function f of x equals to x from 0 to 2 pi. Now, the other part of the question was to find the value of this summation using series obtained in 2 and what we have obtained here. So we want to find what is the value 1 plus 1 over 2 squared plus 1 over 3 squared plus 1 over 4 squared plus 1 over 5 squared, etc. Now, for us to get the answer here, so remember that in the series in the first case is question 2 was x squared. So just say from equation 2, we have that x squared was the same as 4 pi squared over 3, and then plus 4 summation n from 1 to infinity of cos nx over n squared minus 4 pi summation n from 1 to infinity of sine of nx over n. So this is from 4. And then from question 2, not from equation 2, but from question 2. From question 2. Now, question 3, we have obtained that x is given by pi minus 2 summation n from 1 of sine nx over n. So therefore, let's call this one question 1, and let's call this one question 2. So equation 1 is the solution for question 2. For question 2, this is the solution for question 3. So we see clearly that from equation 2, which is the solution of question 3, we have, let's make this one the subject. So summation n from 1 to infinity sine nx over n will be, so pi minus x, and then I need to divide by 2. It's like I divide everything by 2, and then I take this one to the left. So this is what I have. So I'll call this one question 3. So it means that then I can replace where we have this summation of sine nx over n from n1 to infinity by this term here. So say, replacing 3 in 1, we get x squared equals to 4 pi squared over 3 plus 4 summation n from 1 to infinity of cos nx over n squared, and then minus 4 pi, but then where we have this one replaced by what we have obtained here, pi over 2 minus x over 2. So that we have x squared equals to 4 pi squared over 3 plus 4 summation n1 to infinity cos nx over n squared. So this time this one we get minus 2 pi squared plus 2 pi x. And then let's make this the subject. So we have, in fact, I can multiply everything by 3 so that I remove this denominator here. So I'll have 3x squared equals to 4 pi squared plus, so 3 by 4, 12, summation n1 to infinity of cosine nx over n squared minus 6 pi squared plus 6 pi x. So that now I have, so this and this one are like terms, so I have 12 summation n from 1 to infinity of cosine nx over n squared equals to 3x squared plus 6 pi squared minus 4 pi squared and then minus 6 pi x. I've simply taken these terms to the opposite side and left with 12 and this summation. So this tells me that I'll have 12 summation n from 1 to infinity of cosine nx over n squared equals to 3x squared. So this will be now 2 pi squared minus 6 pi x. And then let's make the summation the subject. So this tells us that summation n from 1 to infinity of cosine nx over n squared equals to, divide everything by 12. So we have x squared over, I just say 1 over 12 into 1 over 12 into 3x squared plus 2 pi squared minus 6 pi x. That's what we have. And now we write this one in expanded form as cos x when n is 1. When n is 2, we'll have cos 2x over 2 squared plus cos 3x over 3 squared plus cos 4x over 4 squared plus cos 5x over 5 squared plus other terms should give us 1 over 12 into 3x squared plus 2 pi squared minus 6 pi x. Remember, we want to get the solution for this series 1 plus 1 over 2 squared plus 1 over 3 squared plus. So the thing that if we are able to see how we can get 1 in the numerators, then the denominators for this are actually agreeing with what you need to get. So the thing that cos of x equals to 1 when we let x to be 0. So therefore, when you let x to be 0, cosine of 0 is 1. This is 1 over 2 squared. This will be 1 over 3 squared, 1 over 4 squared, 1 over 5 squared, equals to 1 over 12 into, so where there's x put 0, so 3 0 squared plus 2 pi squared minus 6 pi times 0. So this part will be 0, this part will be 0, so it means 2 pi, so 1 pi squared. So 1 plus 1 over 2 squared plus 1 over 3 squared plus 1 over 4 squared plus 1 over 5 squared plus other terms equals to 1 over 12 times 2 pi squared. So which is the same as, so 2126 pi squared over 6. So therefore, the value of 1 plus 1 over 2 squared plus 1 over 3 squared plus 1 over 4 squared plus 1 over 5 squared plus other terms is equals to pi squared over 6. So this was the required solution. This is the last step. Thank you.